All right, section 7-1, functions. All right, example 1 says determine whether each relation is a function, and you are to explain. So here's A. This is a confusing topic, so we're going to try to explain this a multitude of ways. The first one I'm going to use is going to sound funky, but every one of these coordinates here is in x and y, right? And the y value, right, the y name, just it sounds kind of like the word wife, right? Y and wife. And so whether we determine if this is a function or not, what we're going to say is every x, which we're going to say the x is the husband, every x only has one y, right? So every husband only has one wife. And so we check the -3, right? This is the first one. This -3 only has this y as 1. Now, is there any other x values where there's a -3? If you look at all these, you would say no, there is no other. So that husband only has one wife. So far, yes, this is a function, right? This is a good relationship. The next one is -2. Is there any other -2s as an x value? And there are none. So that husband only has one wife, right? How about the -1 husband? Well, there are no other -1 husbands. So that husband only has one wife. So far this is still yes. This husband of 0 only has 10 as a wife, and this husband 1 only has 13 as a wife. So we call that yes. It is a function. All good relationships there. I know, like I said, this is a little bit confusing. It's a confusing section, but that is basically an easy way to look at this. Now, if we were to see another x value on here that was repeated, say any of the -3, -2, -1, 0, or 1, and then we found that that one had another y, a different y than the one that they already put on here, then we would say no, it's not a function. But let's go ahead and go to the next one here, part B. And part B says, again, we're just determining if this is a function. So what we do is we look at every husband. We've got 5, 3, 2, 0, -4, and -6. Do all those husbands only have one wife? Yeah. 5 only has 1, 3 only has 3, 2 only has 1, 0 only has 3, -4 only has -2, and -6 only has 2. Now, what you might see here is that the y value, the wife, you see this 1 and 1. Now, here's what I'll tell you. So that wife has 2 husbands, right? That wife has a 2 and a 5 as a husband. And in this situation, that doesn't matter. So the only way we're looking at this is we're making sure that every x value only has one y value. All right, so it passes this situation. So again, this is a yes. It's a good relationship. Even though the wife has a couple husbands, in this case we don't care. For this type of question, we only look at the husband. I know that sounds weird, but I found that that's a kind of a funny, comical way of trying to look at this. Hopefully that helps you remember it a little bit better. Every x only has one y value, right? So let's just take that situation and let's just go more. Let's just say, for instance, we had one more point at the end here of 2, and we'll say that 2 has a y value of, we'll just say 10. We're just making this part up. So let's say we came into part B and this was the example. They actually had a 2, 10 at the end. In this situation, that situation would be a no. This is not a functioning relationship because we've found this husband 2 is repeated twice, but the husband has 1 as a wife and 10 as a wife, and that's not allowed. All right, so in that situation, if we added that extra point, that would be a situation where no, it is not a function. Now, if that 2 had another 1 again, and this wasn't a 10, it was 2, 1, and 2, 1, that husband only has the same wife. It's just, we saw him at the movies, and then we saw him at dinner, he's with the same wife, so that's good. We consider that to be a function yes. All right, but just trying to give you all examples here so you understand it a little bit more clear than before. All right, example 2, if you read along with me here, says determine whether the graph at the right is a function, explain your answer. So we're going to do something here. Now this example could have been worked on example 1 also. Could have worked on example 1. Above in the notes you will see the words vertical line test. And here's what that is. Vertical line test is a way to test yes or no if this is a function or not. So what you do is you draw any vertical line and you try to see if that line hits the graph more than one time. Well, in this case, for the line that I drew, it hit once, twice, and 3 times. So here's, just to correlate this to what we just learned, here's a situation where we found one husband. So this is the same x value with a different y value there, a different y value there, and a different y value there. So we found one husband that has 3 different wives, right? So in other words, that would be a no. This fails the vertical line test. This is not a function, right? Every x value should only have one y value, and in this case we found where this x value has 3 y values, and that's not allowed. We can't have that. Now, if we were to draw a vertical line, say over here, you can see that it's only going to hit the graph one time, which is fine. I mean, that's okay, but the problem is we've found a lot of other lines, and what we do is we draw any vertical line. If you can draw a vertical line that hits the graph more than one time, then it fails, right? So you can find one that only hits it once, but for this graph, there's all kinds of vertical lines that you could draw that would hit the graph more than one time, which means you found a lot of different x's, a lot of different husbands with different y value situations, all right? So this is a no. All right, we're going to go back to example 1, and what I did here was I graphed example 1a. So you can flip back in your book to page 359. This is part A. So I've graphed -3, 1 down at the bottom. I've graphed, this is -2, 4, -1, 7, 0, 10, and 1, 13. And I just wanted to show you that, you know, by graphing this, we can do the vertical line test. So if I were to draw any vertical line, would it hit the graph more than once? So when I draw that vertical line, it didn't hit the graph at all. The graph is those 5 points, right? Not any line, it's the 5 points. If I draw that vertical line, doesn't hit any points. But if I draw a vertical line right here, it hits the graph one time, which is allowed, right? We found a husband that has only one wife. If I draw a vertical line on that one, again, only one husband that has one wife. That's good. That line, same thing, one husband, one wife. So all these situations have, if I were to draw a vertical line, would only hit the graph once or no times at all, that's why that answer was yes when we did that a little bit ago. All right. The only time that this would not work, remember, is if we draw a vertical line, it hits the graph twice, which would mean we would have, let's just make up an example here. I've already got that dot there. Let's say I have another dot directly below it. Right, so that vertical line that I drew for that one, that has, the vertical line is hitting the graph twice, right? Those 2 points are where it's hitting the graph twice on that vertical line, which means I found a husband with one wife there. I found the husband with the same husband with a different wife there. That means it fails the vertical line test. If that were the case, then that would be a no, all right, if you had that extra point. So that's all you're looking for. Sometimes graphing it can give you a visual. You don't want to find situations where drawing a vertical line would hit the graph more than once, and then it would not pass that test. All right, again, example 1 here, again, on part B, we're just redoing the problem. So what I did was I graphed all those points, 5, 1, 3, 3, 2, 1, 0, 3, -4, -2, and -6, 2. So again, if I were to draw, is there anywhere I could draw a vertical line that would touch the graph more than once. And you should be able to see this pretty clearly that that answer is a no, right? Only once, only once. Here's a only once, only once, only once. The only way that this would fail is if you were to have another point above or below any of these other points, which would make two dots in a vertical line. So that would be a no. But in this case, again, the answer is yes. It's the same answer that we had before. All right, guys, that is the end. I'm not going to do example 3. That one is another, I think, easy one compared to what you've already learned. All right, best of luck.